Welcome all. In this video, we will learn about introduction for 6lowpan application. Students will be able to explain 6lowpan application and its challenges for designing wireless sensor network. For 6lowpan application. The Internet of Things make use of most of the same application protocol used in the Internet for communication between machines and services for auto configuration and for managing nodes and networks. Application protocols are equally important for the wireless embedded Internet with 6LoWPAN. 6LoWPAN is challenging in this respect. The limitation of 6LoWPAN, such as small frame size, limited data rates, limited memory, sleeping node cycles, along with the mobility of device, make the design of new application protocol and the adaptation of existing one difficult. All the protocol mentioned for the application can be run over the same IP network infrastructure simultaneously. IP uses when what is often called a horizontal networking approach. Although the Internet Protocol provides basic packet networking over heterogeneous link, it is UDP and TCP that allows for the large range of application protocols by providing best effort and reliable connection-oriented multiplexed communication between application processes. Protocol use a socket-based approach where process endpoints are identified by 16-bit source and destination port identifiers. These are commonly called Internet socket or network sockets. The communication between any two endpoints is uniquely identified for each transport by a fourth tuple consisting of the local and remote socket address. This chapter introduces application design issues and protocol related to 6LoWPAN. Common protocol paradigms such as real-time and end-to-end and web service along with their applicability of 6LoWPAN are considered here. Finally, a subset of interesting protocol usable with 6LoWPAN are introduced. Protocol covered include Web Service Protocol, MQTT, ZigBee, CAP, Service Discovery Protocol, SNMP, RTP, and SFP. In addition, industry-specific protocols are considered. Although the Internet Protocol provides basic packet networking over heterogeneous links, it is UDP and TCP that allow for the large range of application protocol by providing best effort UDP and reliable connection-oriented TCP multiplexed communication between application processes. IP protocol use a socket-based approach where process endpoints are identified by 16-bit source and destination port identifiers. These are commonly called Internet socket or network socket. The concept is illustrated in figure. The communication between any two endpoints is uniquely identified for each transport by a four-tuple consisting of the local and remote socket address. Application protocol use a socket API to access datagram socket and stream socket transport service along with row socket services within a protocol stack. The different types of socket are completely independent of each other. 6lowpan supports the compressed of UDP port down to a range of 16, which is useful because a 6lowpan usually has a limited number of applications. Networking-related issues including the use of UDP, limited compressed UDP, port space, and performance issues regarding the use of fragmentation. Many Internet protocols today rely on TCP for a reliable connection-oriented byte stream. Instead, 6LoWPAN compatible application protocol mainly make use of UDP, which means the application protocol need to be deal with reliable if needed out-of-order packets and datagram rather than streams. Although 6LoWPAN supports fragmentation in order to handle larger payload coming in from outside the 6LoWPAN, the fragmentation of larger payload increase delay, packet loss probability, and congestion. When applying compression for web services, an important design consideration is whether to use compression end-to-end or to implement it with a proxy. Other existing protocols can or have been slightly adapted to make them efficient when used with 6LoWPAN. These include MQTT, SNMP, SLP and BACnet. Application protocol designed for web, usually based on HTTP/TCP, are not well suited for use over 6LoWPAN. Application protocol used over 6LoWPAN need to take a number of requirements into account which are typically not an issue over general IP network. These issues include link layer. That is, link layer issues include loosely asymmetrical links, typically payload size of 70 to 100 bytes, limited bandwidth, and no native multicast support. Next is networking. Networking related issues include the use of UDP, limited compressed UDP port space, and performance issue regarding the use of fragmentation. Host issues. Unlike typical internet hosts, 6LoWPAN hosts and network are often mobile in nature during operation. Furthermore, battery power nodes use sleep periods with duty cycles often between 1 to 5%. A node may be identified in many ways, example using its UI64, its IPv6 address, or by a domain name, which should be taken into account. Open make use of link layer encryption. Intermediate nodes are subscript to attack request sensitive application to employ end-to-end application level security. If an application is working with the sensitive data, then it should apply end-to-end application layer security. Here, the application itself encrypts payload at the center of the packet and decrypts them at the intended recipient. Many embedded enterprises systems may also deal with sensitive patient or customer information.